Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 454. Please turn to it, page 454. Today is our lesson number 17, day number 17. The very first problem on the page, number 6. Problem number 6. It says if 3 more than twice the number, alright, so we have some number x, we take 2 times of it, twice the number, and 3 more than that. 3 more than twice the number equals 10. One more time, let's see how we come up with this equation here. This is an equation. What's an equation? An equation is a similar concept to a sentence. The word that I was going to use right now, I'm going to start with the digression. I'm going to start with the digression because it's this word that comes to my mind. I want to use it. I want to make sure that you know how to use it properly. And if you do not know what digress means, digress just means to go off topic, which I do quite a lot. But the thing is, whenever I do digress, I always tell you that I'm about to digress. And when I finish the digression, I also point it out that we are done with the digression. Digress is something that we learn on day number 3. In our vocabulary lessons, in our vocabulary lesson rather, the word that I was going to use is, how is the matter with this thing? It came out of nowhere, so I want you to learn it. It's not a difficult word. It's not a difficult word, then why am I making such a big fuss about it? Because I hear students mispronounce this word all the time. Not just students. Sometimes I have seen grown-ups, people who supposedly went to school and colleges, and they go around mispronouncing this word. They pronounce this word as comparable. It's not comparable. This word is not to be pronounced comparable. There is no such word. It doesn't exist in English language. This word is to be pronounced comparable. Comparable. So one more time. A comparable concept to an equation. You see, algebra is a language. That's what I was getting at. Algebra is a language. And just like any other language, algebra is made up of sentences. In a regular language, we call it sentence. The comparable concept in algebra is an equation. You have to be able to read this equation, you have to be able to read this sentence. What does this sentence say? This sentence says that we have some number. If we were to take twice that number and add 3 to it, we get 10. Let's see how they say it. It says 3 more than twice the number. 3 more than twice the number. 3 more means we have to add 3 to it. Then twice the number equals 10. Question simply is, what's the value of 4 times that number? Alright. So subtract 3 from both sides. Subtract 3 from both sides and we find that 2x equals 7. Well, if 2 times x equals 7, then 4 times x must equal 14. That's it. We are done with it. Number 7. Number 7. We are told that we have a, 2a, 4a and 8a. And we are told that a is less than 0. A is negative. It's very important here. Which of the following numbers above is the greatest? Well, you can look at 2 different scenarios just to make sure that you're on the right track. One is to put in the whole number. For example, if a happens to be negative 1, because a is negative, if a happens to be negative 1, so we'll have a negative 1, negative 2, a negative 4, and a negative 8. Which one is the greatest among these 4? Obviously, negative 1 is the biggest one. Negative 1 is bigger than negative 2, and negative 2 is bigger than negative 4, and negative 4 is larger than negative 8. What happens if a were negative? A equals, say for example, negative half. Would this still hold? Well, let's find out. We have A, 2A, 4A, and 8A. So we'll have negative half, we'll have negative half, we'll have 2 times negative half, which will be negative 1, we'll have 4 times negative half, which will be negative 2, we'll have 8 times negative half, which will be negative 4. And of course it will still hold. Of course it will still hold because of the fact that because of the fact that A is negative. So here we have a negative half, and of course negative half is greater than negative 1, and negative 1 is greater than negative 2, and negative 2 is greater than negative 4. So which one is the greatest quantity? The answer is A. The answer is A. A is going to be the greatest one among the 4 because of the fact that it is negative. Therefore negative 1 is a hell of a lot bigger than a negative million. Do you understand? Of course you understand. It's a simple concept. You just have to analyze it in a simple way. Number 8. What they are hoping here, the people who give you the exam, what they are hoping here is that you will be careless, you will not pay attention, and you will immediately jump to the conclusion that 8 times A would have to be bigger than A. 8 times A would have been bigger than A if A had been a positive number. But if it's a negative, then it's a topsy-turvy word. Do you understand? Yes, topsy-turvy. I learned this someday and I wanted to use it, so I did. So here's a picture that is given to us. We are told that this is 4, and this is 6. These are all 90 degrees, which is very important. Because without knowing that, you would not be able to solve this problem. These are all 90 degrees. The question simply is, what's the area of this guy? Well, it's very simple, very straightforward. Look, break it up into 2 parts. If you break it up into 2 parts, you would draw a straight line here. We are told that from here to here is 6. Let's give it a name here. A to B, we are told is 6, which means, let's call it A to C, which means A to B must be 4. If A to B is 4, then B to C must be 2. That's how we're getting a 6 here. And if B to C is 4, then D to E is also, 2. If this is 2, and this must be 2. And this we are told is 2. So this part here is just 2 by 2. And this part that you see here, this big rectangle here, A, B, C, A, B, C, let's call it D, E, and F. D. Okay, this rectangle that you see there, and then let's call it G. Rectangle A, C, D, G, A, C, D, G is simply 6 by 4. This is a 6 by, I made it too complicated, it's not necessary. This is 6 by 4, this is 2 by 2, a 6 by 4 plus a 2 by 2, 6 times 4 is 24, plus 4, the answer is 28. That was number 8. Let's do number 9. That's it, we're done with it. Number 9 is the last one on the page. Let's take a look at it. Number 9. In number 9 we are told that x minus 2 whole squared equals 25. And we are told again that x is negative, which is a very important bits of information that's going to come in handy in a second. Whenever they go out of their way to tell you these things, very obscure, very subtle things, it's there for a reason. Do you understand? Before we do this problem, let me ask you a simple question. If somebody were to tell you that a squared equals 25, what do you gather from that? What do you surmise from that? What do you infer from that? Do you gather anything from it? What must be the value of? I'm looking at my vocabulary list here again one more time. So see if we learn the word surmise. We have not. To surmise something means to infer something, to gather something. What do you surmise from it? What do you infer from it? If you're going to tell me that a equals 5, you're not wrong, but you are only half right. If a squared equals 25, what that tells us is that a is either positive 5 or a is negative 5. And this is how we write it. Together we write it like this. We would say that A equals positive or negative 5. Why? Because it doesn't matter whether it's positive 5 or negative 5. When we square it, we get 25. So this quantity, A must be, where's my pointer? A must be, given the fact that A squared is 25, that tells us that this quantity A must be either positive 5 or a negative 5, which is exactly what's going on here. So what this tells us is that either x minus 2 equals a negative 5 or x minus 2 equals a positive 5. Let's analyze both of them. Let's add 2 to both sides here. And we get x equals to, this drops out, x equals to negative 3 or x equals to, let's add 2 to this side also. And this drops out and x equals to positive 7. Which one is it? Obviously it's not positive 7 because we are told that it is negative. Given the fact that x has to be negative, the answer is negative 3. The answer is negative 3. The answer is D. That's it. I will see you tomorrow, okay? Bye now.